Hello, how's it going? In this video, we are going to keep extending the basic engine that we set up previously, and we're going to get a map up. So I think I mentioned this in one of the comments, but just as a proof of concept, I'm going to basically get a sort of a Wolfenstein style game. You'd be surprised at how good this starts to look after just some basic alterations. So to start with, if you look into the GitHub code, you'll see that I've got another folder in the stage 11 folder. This is what we're up to, stage 11. And this is an editor. If you've got Qt installed in your system, Qt6, you can actually run this. But I'm just using it to make a map. So the basic idea, if I run this, is we have this sort of mappy looking thing. I don't know how much of this we can see, but I can go and load a level that I went ahead and made. And this is the level that we're going to be bringing into our game. So I'm not sure how visible this is, but if we look down, we're going to have the player basically down here, and they can walk around. Every one of these blocks, I'm doing extreme underthinking at the moment. So every one of these blocks is going to have all of the walls around it. And I'll be, basically making levels like that. So let's close that down because I'm just using this to edit the map. And to start with, I'm going to just write out a to-do list. So there are 5 major items that I'm going to go through today. Number 1 is I'm going to define file name constants because I've now got in my images a whole bunch of different textures, and I want to have those constants all defined at a single place. It'll just help. Then after that, I want to basically, I'll say define a map. So currently, like I said, if we were to go into the editor and look at this level text file, it's got the map. If you squint your eyes, you can actually see the components of the map. But we've got like the walls, the floors, the ceilings, and all this. And I'm not going to worry about loading files just yet. It's not super tricky, but I'm just going to hard code it for now. So we're going to have to get that data in and store that in a useful way. Then we'll need to draw walls. Now for every wall, like I said, I'm going to have all 4 sides around the wall. And then the floors and ceilings. So I'm not going to have an open world. I'm just going to have, anytime there's a floor, there's also going to be a ceiling. And then finally, and I've implemented this, it's not super great. There are things we can do, but it's good to have something at least, and that is collision detection. So that our player can walk around and bounce off the walls and stuff. Okay, so to start with, I think it's a good idea just to run this periodically and make sure that we're not getting any errors. So if I run it right now, see? We have got an error. But then this error, if we look down here, is saying, hey, we can't load this stellar.png. And that's actually fine because I'm not going to be using that texture in my game. So we'll just go through and clean this up. We go in here, we've got this thing, we can just get rid of that. And I'm just gonna play around with for a little bit. If I go to my component registry, this has got all the data that I need, but really, I'm not going to use this. I'm just going to use the camera position and direction. So I'm going to get rid of all this. And then if we were to continually run this and keep checking for errors and stuff, it says when we make the transform system. But if we look at the transform system, it was just for transforming that plane, which we're not using anymore. So we can go ahead and delete that. And then also if I look at the render system, we don't need any of this stuff anymore. So we can get rid of that. And then I'll just go to my app, Just clean that up, get rid of the transform system, and just keep cutting away until it's all gone. So attribute error render system, yeah. So I'll just go over to my render system, and upon update, yeah, first up I'll leave that for now. This part here, so I'll just sort of actually okay, great, cool. So blank slate, now we've got absolutely nothing, and then onto this we'll start adding our pieces. So the first part was to define the file name constants, and this is easy enough. I'll just make a file, I'll call it constants.py. Okay, so the basic idea is I'm going to set up a dictionary where the key of the dictionary is the texture number or the object number, and the value associated with that is the file name to the texture. So this will just take a little bit of time. What I'm also going to do is later on I'm going to add doors. So for the time being, I'll just use the sentinel value of -1 to indicate a door. But yeah, let's get into it. There we go. Great, that's a lot of fun. And then I'll define the floor textures. So both the ceilings and floors are going to use the same textures in the sense that they'll be coming from the same folder. They won't literally be the same textures. There we go. Something like that. That's looking good. So now I can go back to my to-do list and say, okay, that item is done. Okay, now, next one, define a map. A little bit trickier. So I'm going to create a new system called a world, very imaginatively. So I'll have world.py, and then inside, I'll do a few things. I'll import basically everything from config, and then we're also going to need to know about the component registry. Okay, so the world is going to manage the data basically for the map, but that map data does need to be saved in the registry so that the render system will be able to see it. But at the point of creation for the registry, it doesn't necessarily know how big the world is going to be. So what I'm going to do is I'm going to go over to the component registry, give it some new fields, go walls, and then I'm going to also give this component registry a method to set the size of the map. At the point of creation for them, well, this is basically the point of creation for the map. We're allocating the space for everything. So we can go ahead and I'll create a bunch of zeros. The size for that will be, and just the smallest data size we can get away with. Cool, excellent. So I'll close that down. And then in the world, the first thing we're going to do is we're going to declare what size we need. So I'll just sort of have this open on the side. So it looks like, if we look here, our width is 27 and our height is 18. So I can take that, set the map size, height 18, width 27. So now what I'm going to do is I'm going to load in the walls, floors, ceilings. And for each of these, like I said, I'm going to hard code it for now. It's not super tricky to read this from a file, but I just want to get it quickly done. So what I'll do is I'll go over to my geometry section here. I'm calling this geometry because ultimately it's going to include both walls and doors. But anyway, I'll copy all of that, bring this in. There we go. That's a big chunk. And then what I'd like to do is I would like to look through this chunk element by element and set the corresponding elements in the walls array. But if I look at this task is starting to look a little similar to how it will be whether I'm doing walls, floors, or ceilings. So what I'll do is I'll write a helper method called load array, which takes in the data just in string form, and then the source, which will be numpy array, and then just as convenience, I'm going to return. And this sets it up so that when I use this, I can write something like self walls is. So even though it's sort of a dummy declaration, because we could just as easily load this thing independently and then set the variable, it's just a nicety. So I'll go ahead first up and return that source. Excellent. And now let's look at actually loading into that array. First up, I'll split the data. That will turn it from a big string into a list of strings. And that's like a flat memory map. So I'm going to be looking through that one element at a time. So first thing I'll do is I'll get my source, set the appropriate element. And then what I'll do is I'll look across by one. So J will go up by one, but I'll need to do some bound checks. So I'll say if we go out of bounds, then reset and go down to the next scan line. You can probably imagine that there's a fair amount of trial and error that went into this, especially the dimensions of the array. That was a really tricky thing to work out. A lot of just printing out raw stuff to the screen. But we've got that, cool. So that should work. And now we can basically do the same thing for everything else. So I'll sort of redefine my data, and then I'll load this into the floors array. And to be honest, we probably don't need to save the floors and ceilings, but we could do it anyway. I mean, we have to load the stuff anyway. So where was I? And then the ceilings. So this has set up the world, but remember that we also have a player in the world, so we'll need to orient our player. Now, first thing I'll do is I'll fetch the data. And then I'll give it some values, and like with everything else, I'll just hard code these for now. So we've got 11 and 15. So I imagine that 15 would be the X and 11 would be the Y, or something. Let's find out. Anyway, I'll do that. Just remembering that Z is playing the role here of Y, sort of, if you look from top down. Anyway, then I'll set the player, something like that. I think that's fine. And that's probably it in terms of loading stuff in. So again, nothing too exciting, but let's go over to our app and we'll bring in that system. And yeah, like I said, nothing too exciting, but if we run this, at least we can, I might have made an error, but no, this is looking fine. Excellent. Cool, so we can go back and say, all right, this bit is done. Cool, okay, render system can draw walls. A little bit here. So what I'm gonna do is I'm just gonna go to my render system, and then you notice that there was this method that I didn't get rid of, set up plane model. Oh, I should probably load textures. Yeah, let's do that as well. So we'll go import all the constants. Okay, and luckily I've got those file name constants defined, so this will actually be quite straightforward. So for instance, let's say we get a dictionary, and then we fill that in. So we go look through the items of the dictionary, and then the index will be the key. We'll go ahead and load the texture using the value. That's it. This will populate all of the wall textures, and then we can do the same sort of thing for the floor and ceiling. As a matter of fact, I just realized it's the same. They're using the same textures and the same file names, so we don't even need to double up. That's between the wall and ceilings. Sorry, floor and ceilings. There we go. Cool. That loads everything in. Now, the next part is I'm going to stop stalling, and I'm going to set up not my plane model, but I'm just going to set up all my models. So there's a little bit here. So what we've got is we've got a block, and we want to have planes with a width, a height, a breadth, whatever, of 1, which means essentially an offset of 0.5 in every direction, and then we want a whole bunch of them. So for instance, let me just go put this. I'll just keep that for now. So what I'm going to be doing is I'm going to be using the colors array to choose the color of each face of each wall. Because if I have everything just blended completely white, then it will be hard to tell the directions for the faces, because a lot of these textures are going to look the same. But it's probably not intense enough to warrant a full lighting calculation. So I'll just pre-bake the colors. At the moment, I just care about this face here. Okay, texture coordinates, that's fine. Normal, I do not need. Okay, and then the indices. So what I'm going to have is I'm going to have actually a bunch of different indices. So I'm going to have, let's say, the vertex indices for the wall, which is just this one here. And then I'm going to have the texture indices for the wall, which, yeah, right now, these are all going to be the same. Okay, so I'll go down to this draw function, draw filled, and I'm going to modify this a little bit. Instead of draw filled, I'm going to draw a wall. I'm going to have, maybe instead of position, I'll call this element, and that's basically the material or which texture to draw, and that'll be an integer index. And then here I'm going to take row and column. Okay, so the first thing I do is bind the appropriate texture. I go wall textures, just like that. Then I'm not going to do any of this stuff, but what I am going to do is basically set up my transformation matrix, because we've got this row and column number. We want to take all that wall data and draw it at that row and column. So I'll go up above. I've got this apply rotation. I'm actually going to generalize this and call this apply transform. I know. So I'm going to pretty much get rid of a a lot of this because this is just a straight translation. It's nothing else. So I'll go GL, translate, and then, so again, the devil's in the details here. The row number, if we were to look at the map like we've got here, this row number is going up and down. But if we're, say, here and we're looking in this direction, that's our forwards, that's actually our negative z-axis is out here. And so this x-axis is actually playing the role of the row. So for the x component of the translation, I'll put in the row. For the y component, that's like the height change, nothing, okay? For the z component, that's my forwards and backwards here, and that's the column of the matrix. So it's something like that. Okay, so I'm going to simplify this a little bit further. Because I don't have a general problem, I have a pretty constrained problem. Right now I'm just drawing a single plane. Lighting, we do not need that. Okay, again, we'll just fetch the appropriate color, blend that, use it for the whole face. I'm just gonna fetch a few other bits of detail, and the purpose here is really just to reduce the size of the source code, make the lines a little shorter. But anyway, I'm gonna get the description of all the texture coordinates. And similarly, I'm gonna get the description of all the vertex the vertices. So we've got the face index, and then within that, we're gonna have the point index. And again, this is a very constrained problem. Each one of these is just a single plane. So it's just like that. Okay, so we're gonna not worry about color. We've already handled that. What I'm gonna do now is I'm gonna fetch the actual texture coordinate. Okay, so for context, just as a reminder, we could think of it like this set of vertices, colors, texture coordinates and stuff. These are just like big data buffers, which could be for everything, for the wall, for the ceiling, everything. But then these elements are saying, you know, this set of 4 is a set of 4 points which defines a single plane. And they are indices into these sets. So for instance, the first plane is using this vertex here, and then the vertex at position 1, 2, and 3, just like that. As a matter of fact, yeah, we could make this even simpler, but I'm just gonna leave it like this for now. Oh, and then also, I'm just gonna go ahead, and after I draw that whole thing, I'm then going to reset the transform. Now for drawing this stuff. So I've gone ahead and cleared the color buffer. I'm gonna loop, so I'll go, again, just hard code it for now. I know it's a little silly at the moment, putting a continuous statement. Oh, actually, I don't even think we need a continuous statement. I'm just looking at my finished code. This is fine. Okay, cool. So again, we basically look over the whole map. We look at the corresponding entry in the walls array. And then if we've got something non-zero, there's a wall there, so we should draw a wall. Yeah, I'm feeling game. Let's have a go. Excellent. Right, so we're checking this thing, but we haven't really saved it. No worries, let's go self walls. And while we're at it, okay. Of course, course it doesn't work because I haven't actually applied the transform. I was getting this a few times. If you continually push on matrices and you run out of run out of memory or something, it causes an error. And similarly, if you continually pop matrices, that will cause an error as well. Looks like this thing has been sized inappropriately. There's potentially a bit of an error there. Something's a little off. I may have to revisit that. Let's see. Okay, cool. So looking at this right now, I can see I've got one wall, precisely one wall for every object. And I can walk through and it looks good. Okay, cool. So where I'm going to go from here is just a bunch of coding, and for each of these objects I'm going to create the other 3 walls. Yeah, that should be fine. Okay, so then in terms of the wall colors, I'm just going to hard code a few of these values. And I'm happy with the texture coordinates. I'm happy to use the same texture coordinates pretty much for everything. But yeah, for these vertices, they're going to have to go up in sets of 4. Cool, okay, fingers crossed. So then I'll just go down to this loop and I'll draw 4 planes. Cool, okay, so it looks to me like everything is working. Now, interestingly, we can peek behind the hood, so we can hop inside this wall and we can see that actually every block has all 4 pieces, and there's some ugly like Z fighting going on here. In a future video, I'm actually going to work on optimizing this away, detecting when the blocks are colliding, so we don't have that extra step of drawing all the blocks. But I am surprised actually at how good this looks for what it is. Anyway, so we've got that. We can draw walls, that's done. Okay, the next one is floors and ceilings. Now, in order to do this, I'm going to need to modify my vertices so that I've got the floor and ceiling vertices, or the floor and ceiling faces as well. Okay, fingers crossed. Let's find out. So then, there we go, super simple. And we can duplicate the same for the... Okay, now, as for these functions, I'm going to split them into 2 functions. The reason for that being that they actually take, they're almost the same, but they take different elements, essentially. So we'll go draw floor. Yep, we'll fetch the appropriate floor texture. We'll still apply transform as normal. What I'm actually going to do is, we know that floors and walls are mutually exclusive. There's always one or the other. So what I'll do is, in the case where we haven't got a wall, there's a possibility we've got a floor and a ceiling. In that situation, ahead of time, I know I'm not going to apply any lighting. I'll just give it a blanket white blend. And I also know that I've only got one face, so do I need to worry about that? There we go. I think that's fine. Then we can take a copy of this, and that will be the ceiling function. Cool. Okay, so I've got my functions to draw my floor and my ceiling. Like I said, this is just the most naive way to do it, really, at the moment. But if it works, then it works, and we'll worry about performance later. So what I'll do is I'll query the ground, basically. And then in the case we've got something on the ground, then it's time to draw both a floor and a ceiling. So we'll go draw floor, and then we'll go draw ceiling. Remembering to fetch a different element, otherwise the floors and ceilings will literally be the same texture. Okay, so let's give that a go and see what that looks like. There we go. Isn't it amazing how sort of, I don't know, maybe this looks bad, I don't know, but I'm surprised at, yeah, how straightforward and sort of complete this looks. I guess having complete artwork gets it a lot of the way anyway. Right, so that's that. But like I said, we don't really have collision checking. Like, we still can walk through all of these things. They look sort of funky. But yeah, hey, that's a start. So we can go to our to-do list and say, yep, this one is done. Okay, last one, collision detection. So the way this is going to work is we have this world object, which sort of has an idea of the map. And instead of the input system directly moving the camera, what the input system will do is set a velocity for the camera, and then it will be the job of the world upon its update to check the velocity and check if a collision would occur or not. So first up, I'll go to my component registry, and I will give us a camera velocity. Okay, that's fine. And then I'll go to my input system, and in my input system, I'll basically save that velocity. And then down here, this is where I'll be updating it. So first up, I'm going to zero out the velocity. And then down here, instead of modifying the position, I'll be, modifying the velocity. Okay. So then I'll go over to the app. I actually go to the world, and I will give the world an update function. And just while I'm at it, I'll also save the camera data. Then I'll go to my app and I'll say, okay, we've got a world. So the input system will set the velocity of the camera, and then the world will apply that velocity. And now the basic idea, and there are different variations. I'll do a simple variation first, and I'll modify it a little bit. We'll see how we go. So remember that the horizontal movement is in the XZ plane. So let's take the X first of all. I want to get the player's position, and I want to look ahead by a little bit. And what I'll be doing is I'll be checking each component of the velocity independently, and turns out that does a pretty good job of creating a smooth sliding motion. Okay, cool. So in a pinch, that's basically done it. We can go over and give this a shot and see how this goes. Maybe it won't work, I don't know. So we can walk, and you can see that, yep, we are pretty much capped. Now it is true that in some cases, you see, we can sort of see through, so that's not great. But in a pinch, I'm pretty happy with this system. And actually, I'm going to leave it. That's fine. That's good enough. If you have extra time, you can play around with this. But yeah. Anyway, so that's it. In this video, we basically set up a 3D world. In the next video, we are going to maybe look at culling some of these walls so we're not drawing a whole bunch of stuff. And then after that, we can actually add doors and do some sort of visibility checks so that we're only drawing certain regions. But anyway, that will be it for now. I hope you enjoyed, hope you had fun, and I will see you again soon. Bye.